Okay, let us start with the class. In the previous class, we have discussed about the IO section, did not? We have dealt with the rack, what is chassis, memory, chassis and rack, the number of slots, what are slots, right? And how the data is stored in the slot using the word and the bit format. Right? And this format we explained in the previous class. Format in which the data is stored in the file or the data is stored in the rack system. Then next we will move on to what is called as discrete IO modules. Discrete IO modules. So screen is clear. Students, screen is clear. Students.
Yes, sir.
Are you able to hear me? Oh,
Yes, sir.
okay, fine. Next is discrete. Okay, thank you. Discrete IO modules. Okay. So as the name itself indicates that it is discrete, means it is digital in nature. Digital means it has only two states, that is on state or the off state. Okay. Such a system is called as the discrete system. Discrete input bar output modules, IO modules. So discrete in module means the module, the input module or the module which has only two states, that is on state which has the condition of 1, okay, and the off state which has the condition of 0. So such input modules are called discrete input modules. Similarly for the output modules, if the output module has two states on and off, one indicating on state and the 0 value or the 0 bit indicating the off state, then it is called as the discrete output module. So such of the input output modules are called as discrete input output modules. Now, in comparison to this discrete input output modules, we have analog modules. Is it not? Analog modules. So what is the difference between analog modules and the digital modules? In analog module, the signal is continuous. You have gone through the analog signal in when you are studying in your first year the electronic circuits or in your basic electrical, you have seen the analog signal. It is continuous in nature, the sine waveform. Yes, so that is the continuous signal which has infinite number of values called the analog signal. Whereas in digital there are only two states, either the high state or the low state, that is 1 or 0, on or off. So such of the modules are called as the discrete input output modules. Have only two states, either 0 or 1, that is off or on state. The most common type of IO interface module is the discrete type. So this discrete input output module was used originally. Originally, the PLC system that existed, they were only of the discrete type. They were only of the discrete type, that is, they had only on state or the off state. But they were not able to to be connected to the devices which are of analog type. The field devices were which were of analog type were unable to be connected to the PLCs. So they could not handle the analog type of modules or analog type of field devices, right? But later on, as the time evolved, it so happened that now at existing both analog and digital IO modules are present. That is, the PLC can handle the analog signal as well as the digital signals. The discrete input devices are, so here I have shown the various discrete input and output devices. So these are the input devices, discrete input devices. So what you all are seeing here at the bottom, these are the input devices. That is a push button. Push button you have seen in your houses, right? They are the normal push buttons. Okay, the switches that you operate, the on-off switches, they are of the push button type. Okay, when you push them, they are on, and when you release it, they are off. Then next is the selector switch. This selector switch is nothing but it is of the rotary type. Rotary type. Okay, so when you operate it, here it is having only two states because it is a discrete in nature. Okay, it cannot have more than two states. It is discrete. So this is a rotary type of switch, the selector switch, wherein when you operate, when you rotate it once, it is on state. When you rotate in the other direction, other way, it is off state. So it is only on or off. But it can so happen that this selector switch or the rotary switch can have more than two positions. For example, when controlling the speed of the fan, electric fan. Okay, so that there these selector rotary switches are used which are having more than two positions. Okay, if it is required to operate only on and off, then only two position selector switch is used. If it is having more than two positions, then the selector switch which is having more than two states are used. Rotary switches or selector switches which have more than two states are used. Next is the limit switch. This is the limit switch. Limit switch, as I told in one of the classes, it is the switch in which when the current reaches its limit, it is operating. And when the current is not to the required extent, to not to the required limit, then it is in the off state. Only when the current reaches its required level, the switch is turned on or the limit switch starts to operate. The last one is the proximity switch, what you are seeing, the proximity type of switches. So the name itself indicates proximity. Proximity means the nearness. When the distance between the object and the sensor or the switch is such that it is at a suitable distance, then the switch will try to operate. It will start to operate, and its contacts will get closed, and the current starts to flow. That means it depends on the distance between the object and the switches. Following here, it depends on the distance between the object and the switches or the sensors, right? So when there is a particular distance between the object and these switches operate, the contacts get closed, and the current starts to flow. So all these are the input devices, discrete input devices, modules, that's push buttons, selector switch, lead switch, and the proximity switches. The next is discrete output devices. So these discrete output devices are indicator lights. Indicator lights, just like your vehicle indicator lights. So when you turn them on, they're blinking on, off, on, off. Right? So they are called the indicator lights. Next, signaling column. We are seeing here the signaling column, the various colored lights which will blink, start to blink based on the position on and off positions. So this is called as the signal column. Then the relay. Relay, as we know that it's a switch. When the current reaches its particular value, right, its contacts gets closed and the current starts to flow in the other part of the circuit. Okay, and when the current is not to the required level, then the contacts will be in the open state. The contacts are not closed. There is no contact established, right, and hence the current cannot flow. So such of the switches are called as the relays. Then last one is the motor starter or the starter, which is used to control the power to start the motor. Motor starter is the device, the output device used to control the power to start the motor, that is the field device which is connected to the output module. Okay, so all these are the discrete input and output devices. So what are the discrete output devices? Just now we've gone through indicator lights, signaling column, relays, and the motor start. Okay, the discrete input devices are push buttons, selector switch, limit switch, and the proximity switches. Discrete output devices are indicator lights and the relays and other devices. So all these are nothing but on-off switches. They are just on-off switches. Classification of discrete IO includes, that depends on the bit, whether the bit is 1 or 0. If the bit is 1, then it is on. If the bit is 0, it is off. Hence, each bit represents complete information. Every bit, that is 1 or 0, represents the complete information. It represents the status of the device, whether it is an on state or the off state, and it also represents whether the power is flowing in the circuit or the current is flowing in the circuit. If current is flowing, then it is indicated as 1. If the current is not flowing, it is indicated as 0. So what it is, each bit represents complete information and provides status of external contact or provides advice about the presence or absence of the current or voltage in the circuit. Next, each discrete IO module is powered by voltage source. Is not, students? So when we want to use any of the input-output modules, we should have certain voltage sources in order to energize them. Correct? If you are not able to energize, then they will not turn on. Every device requires some energy, so that energy is provided by the voltage source. Here, as you are seeing in the next figure, this is the power supply of the PLC. This is the entire PLC, what you are seeing here. This is the power supply of the PLC. This provides power to the back plane. This is called as the back plane, right, of the rack. This is a rack arrangement. As you can see here, there are different racks: first bottom rack, middle rack, top rack. Correct. So this is a rack arrangement in which there is this is the slots or the connectors, power connectors. Okay, from where the power is sent to the IO modules. So this is the power supply block which is sending the power to this back plane of the rack system, and from the back plane of the rack system, the power is sent to the input module. These input output modules. Clear here? IO modules are available at various AC and DC voltage ratings. So input output modules are available at different voltage and current ratings. Modules receive voltage and current for proper operation. That's what I told when I explained with the figure here. Modules receive voltage and current for proper operation from the back plane of the rack enclosure in which they are inserted as shown in the figure here. This plane in which the rack is inserted, from this back plane, the power is supplied to the, or the current or the voltage is supplied to the input output modules. Power is now how this backplane power is obtained. Yes, backplane power is obtained from the PLC module power supply. So the PLC module, this is entire is the PLC module, and this left portion what you're saying is the power supply module of the PLC. This supplies power to this backplane or the connector slots, the connectors, and from this connectors the power is sent to the two modules. And it's used to provide power to the electronic circuit on the IO module board. So what it is, from this plane connectors, the power supply is sent to the electronic circuit which is there on the input output modules. Which are the different module power supplies? The module power supplies are rated at, what is the rating? That is the specifications of the power supplies of the PLCs. So they are having the specification of 3 ampere, 4 ampere, 12 ampere or 16 ampere. That means 3 ampere. What is the meaning of 3 ampere? Maximum 3 ampere current can flow in the circuit. It can sustain, or it can, the maximum power, the current that can flow in the circuit is 3 ampere. If the 16 ampere power supply module, then the maximum current that it can withstand, or the maximum current that can flow in that module is 16 ampere. It's like this. Are you following here, students? Yes, please. Are you following here, students? Are you following here, students? Yes, please.
Can you explain the proximity input modules?
Okay, I'll come to that. Now this is a proximity switch. Okay. Now proximity switch means what? Proximity. The name itself will indicate. Proximity means nearness. The meaning of proximity is nearness. Okay. That means as the object comes nearer to the this switch, proximity switch, it will sense the distance. There is a certain cutoff. That means if the distance is this much, say the distance is say 5 centimeter, okay, then it will start to operate. The proximity switch will sense that signal based on the distance, okay, and that signal it will convert it into an electrical signal. The proximity switch will convert the distance based on the distance, whatever signal it is receiving, the nearness, the distance, it will sense that, and based on that it will convert that signal into an electrical signal. Okay, so then the switches will operate based on the contact closing or off of the opening of the contacts, right, and the current will flow in the required circuit. Okay, so what is the meaning of proximity? Proximity means nearness. Remember, the meaning of proximity is nearness. Okay, so depending on the distance between the object and the switch, okay, some field device, okay, you want to control the field device, input device. Now how will you come to know that there is an input device? You will come to know when you bring that input device and that device nearer to this proximity switch, right? And when it is bringing nearer, when you bring that object field device nearer to this proximity switch, what will happen? Depending on the distance, the cutoff, that is a rating that is maintained, and the specification that is maintained, based on that specification, based on the distance required, cutoff distance, what will happen? The proximity switch will operate. It will convert the required signal from the required signal to electrical signal, the given signal to the electrical signal, and that electrical signal operate in the circuit, or that will flow in the required circuit. Is it clear now, students? I hope I am clear to you. Proximity switch.
Yes, sir.
Yes. Did you? Okay, fine. Now the next figure, what we are seeing here is the discrete input module. This is the discrete input module block diagram. It is for the input module or the input section, a discrete AC input module block diagram. Here you are seeing the line terminals, input terminals L1 and L2, which is where we are applying the 120 volts AC signal. Okay, so why it is 120 volt AC signal? Any idea? Anybody, any idea why it is 120 volt AC signal? Why not 230 volts? Yes, please. Anybody knows about it? 120 volt AC signal. What is the reason? Why not 230 volts? See? Yes. Any idea here, students? Because the different countries follow different supply ratings. Okay, in India we are following a standard of 230 volts 50 hertz. This you have studied in your basic electrical subject in your first year level. Okay, the standard is 230 volt 50 hertz. If you take the countries like America, okay, US, there the voltage rating is 120 volt 60 hertz. 120 volt 60 hertz. Okay, so different countries follow their own standards, right? Follow their own standards of the voltage and frequency ratings. In India it is 230 volt 50 hertz, whereas in the US, in America it is 120 volt AC and 60 hertz frequency. Okay, now this input signal we are applying here. This is the push button switch, what you are seeing here, a normal switch. When you push it, the contact will get closed and the current will start to flow. Correct. So it is a push button. When you close it, the contact gets closed and the current will start to flow here. When the current starts to flow here, the input signal arrives at the bridge rectifier. Correct. It is a bridge rectifier. In the next figure, it will be much clearer to you. What is this bridge rectifier? What are the different blocks that are used? What is their circuits and all? Now, what is a bridge rectifier? What is a rectifier, students? You have studied in your electronics subject in your first year level. What is a rectifier circuit? Anybody remembers? Rectifier circuit. How many types of rectifiers are there, or what is a rectifier circuit? Yes, please. Anybody remembers?
It
Whatever you have
converts
studied in your first.
AC signal to DC signal.
Correct, exactly. It converts AC signal to DC signal. It is a rectifier. Very good. So, rectifier converts an alternating current, AC signal, sine wave signal, into a DC signal,
Diode
continuous
rectifier.
signal. Diode rectifier, exactly. Diode rectifier. You are right. So here there are two types of rectifiers basically. One is half wave rectifier, another one is full wave rectifier. Half wave rectifier, what happens when you're applying the sine wave input to the half wave rectifier circuit? Okay, the output whatever you are getting is only one portion. That is either you get a positive pulses, right, or you get the negative pulses based on the position of the diode, orientation of the diode. Correct. But when you consider the full wave rectifier, in full wave rectifier there are two types. One is center tapped, another one is bridge rectifier. Correct. So when you are considering the center tapped rectifier, there is a coil, secondary coil, and there is a tapping. In between there is a tapping. Just try to recollect what you studied in your first year level, right? So that is how there is a center tapped rectifier. It is called a center tapped full wave rectifier. But here what rectifier we are using is bridge rectifier. Bridge rectifier, we require four diodes. We require four diodes arranged in the form of a bridge. I'll show you that next circuit, how it is in the form of a bridge. So such a circuit or rectifier is called as the bridge type of rectifier. From bridge rectifier, the AC signal is converted into DC. It arrives at the Zener diode level detection. Zener diode level detection. Here there are mainly two block students. One is the power section, another one is the logic section. In the power section, this is what we are explaining now. It is the power section. So next is the Zener diode level detection. Zener diode level detection. Zener diode is just like an ordinary diode only, okay, wherein it conducts in the forward direction. When you are applying the voltage, it conducts in the forward direction. The current flows from the anode to the cathode, right? When you are applying the voltage in the reverse direction, when you apply the voltage in the reverse direction, okay, when you change the polarities of the supply voltage that you are applying to the Zener diode, okay, what will happen there is when you are applying the reverse voltage, for some values of the reverse voltage, the current will be very less. It is a leakage current, what we are calling. Current is very less current flows in terms of microamperes or nanoampere current flows. But after certain voltage is reached, called as the Zener voltage or the breakdown voltage, suitable amount of current that is flowing. Certain current or the suitable amount of current flows whenever this Zener voltage is reached or the breakdown voltage is reached. Okay, so this is what is called as the Zener diode. Zener diode. Now, what is the advantage of using this Zener diode? Advantage of using this Zener diode is when the voltage reaches a particular value, it will detect that. Now, as I told, Zener, there is a Zener voltage in the when you are connected the diode and when you are changing the polarity of the supply voltage, and then in the reverse direction when you are changing the polarity of the supply voltage, right? So you are applying the voltage. That is called as applying the voltage in the reverse direction when you are changing the polarity of the supply voltage. Okay, so when it reaches a particular value called as a Zener voltage or the breakdown voltage, what will happen? Suitable current or some magnitude of current which is more than the reverse current, which is more than the leakage current. Okay, what it flows when we start to apply the initially when we start to apply the reverse voltage. So the voltage will be more than that when you are applying the Zener voltage. Initially, when you apply the reverse voltage, microampere or nanoampere, so very less current flows. When you reach to the voltage called as Zener voltage or the breakdown voltage, that when that particular voltage level is reached, power supply voltage is reached, then the current that is flowing in the Zener diode is more. Okay, large current flows, certain suitable amount of current flows. Okay, so at a particular voltage level, the current is flowing. So this property of the Zener diode is used in finding the voltage level of the bridge rectifier. The AC voltage is converted to DC by the bridge rectifier. Now this Zener diode, what it will do? It will detect how much is the voltage. It will find out based on the current that is flowing. It will detect how much is the voltage based on that Zener breakdown voltage. Okay, so once it finds out that voltage, then that voltage detected, then it is applied to the coupler circuit or the optoelectrical isolation circuit as it is called. In this optoelectrical isolation circuit, it is mainly called as the optocoupler. Optocoupler is circuit which provides electrical isolation. It provides isolation between two circuits using the light signal. I'll explain you that in the next diagram. Optocoupler or optoelectric circuit is a circuit which provides separation between the two circuits based on the light signal or using the light signal. Then from the optocoupler circuit, the signal is applied or the voltage is applied to the logic circuits. The logic circuit will turn on the LED. The logic circuit will turn on the LED. Okay. So like this, based on the voltage that we are applying, the input voltage that we are applying, finally the LED is turned on. What it indicates here, students, when the LED is turned on, it indicates that when the LED is turned on, based on the status of the on of the LED, it indicates that the input voltage has been applied. That means if input voltage has been applied, the LED is on. If input voltage is not applied, the LED is in the off state. Okay, so it is like that. So based on this, the logic circuits or the circuits that are connected to this LED, they are further converting the voltage from high voltage to low voltage DC. It is called as regulating the voltage. Voltage regulators are used, okay, which are converting high voltage DC to low voltage DC. Then that low voltage DC is applied to the required next part of the circuit, that is the PLC. Okay, so this is the normal block diagram of the AC input module of the PLCs. Okay, hope you are following here, students. Yes, everyone, are you following here? Yes, please. You are following here, students? Any doubts on this block diagram? It will be more clear to you when I explain the next one and take up the next figure. Okay, then if you are having any doubts, you can ask. A simplified diagram for single input AC input module is shown in the next figure. So this is the figure, simplified diagram for the single input discrete AC input module. Here are the input line. It is the same thing. What I just, it is the same block diagram, but individual blocks. So what is this bridge rectifier circuit? It is this. It is this bridge rectifier, right? Then what is Zener diode detection? It is this, the Zener diode and the resistor. What is optocoupler? It consists of the diode and the phototransistor. Okay, so all these are explained in detail considering their circuits. So that is this diagram. So here we are applying the input voltage to the line terminals L1 and L2. From it is applied to the fuse. Can you recollect, friends, what is a fuse? You have studied earlier in your first year level. Can you recollect what is a fuse? Fuse means what? Are you able to remember what is a fuse? Yes. What is a fuse? Fuse you are using in your houses, is it not? It is used in your houses. What type of device it is, or what type of setup it is? It is a protective device, correct? Fuse is a protective device. It is a piece of wire. Fuse is just a piece of wire. It may be a copper wire or aluminum or silver, okay, or it may be an alloy of lead and tin. Right? It's a piece of wire wherein when the current goes beyond the limit, when the current exceeds the limit, the fuse wire will blow out. It will burn out. Okay, thus providing protection to the remaining part of the circuit. So it is a protective device. It is a protective device where when the current goes more than the required level, the fuse wire will burn out and provides protection to the next part of the circuit. That is the protective device, fuse. From fuse, it is given to the push button. The push button is connected to the input module terminal strip. So these are the various channels what we are calling. So the input module channels may be 4 or 8 or 16 or 32. And this we have discussed in our earlier classes, correct? So it may have many number of input slots or the input channels. Here the push button is connected to one of the input channels. From the input channels, this is a field wiring. This is all the field wiring. This is the field side here. The what you are saying to the other side. This side is a field side. Then next is, this is a common point, the negative. So this is just like a positive terminal, L1. Okay, then L2 is just like your negative terminal, minus, which is connected to the common. From the input channel, it is sent to the filter circuit. This R1, R2 and capacitor, they are the filter circuits. It's a filter circuit. The combination of R1, R2 and capacitor, it's a filter section. This filter section will remove the unwanted signals or the noise signals which are present in the signal coming from the push button. Fine. From the whatever signal is coming from the push button or from the input model terminal strip, in that signal, if there is any noise signal present, then that noise signal is removed by the combination of this R1, R2 and C. Okay. So how it removes, it depends on this value of the capacitor, right? It is having its own value. So based on the frequency of the input signal, correct, based on that, the capacitor value will change, and the capacitor will act like either an open circuit or a closed circuit. Okay, if the frequency is more, then it will act like a, the reactance is more, Xc is equal to 1 upon 2 pi Fc. So if C value is more, Xc will be very less, reactance or the impedance or the resistance will be very less. So when resistance is less, the current flowing will be more, correct? It is short circuit. So when Xc is, that is when C value is very less, almost 0, then Xc is equal to 1 upon 2 pi Fc, correct? Xc is equal to 1 upon 2 pi Fc. C value is less, almost 0. Xc will be infinite. So when Xc is infinite, infinite resistance, current will be 0. It is open circuit. So based on this property, it will try to remove the noise signal which is present in the input signal coming to the filter section. From the filter section, it is sent to the bridge rectifier. You know how the bridge rectifier works. This is the arrangement of the 4 diodes which are used in the form of a bridge. Now, when the input signal is the AC signal here, correct? For the positive portion, let us consider for the positive portion. For the positive portion, which are the diodes which are turned on? So this is positive, positive, negative. L1 is positive, L2 is negative. Positive means L1 is positive means this diode, it is connected to positive, negative to negative. It is forward biased. Then this diode also is forward biased, positive to positive, negative to negative. Other 2 diodes are reverse biased, correct? Because positive is connected to negative, negative to positive, so they are reverse biased, opposite. Then how the current will flow from the L1 through this diode, then through this R3, then from this it comes to this diode, it flows through this diode, and then to the negative terminal or the common or the L2 terminal. Now if we consider the negative half cycle means L1 is negative, L2 is positive. Polarity is changed. L1 first it was positive, L2 was negative. Next time L1 is negative, L2 is positive. So when L1 is negative, negative to negative, this diode is forward biased. And here also negative to negative, so this diode is forward biased. Other 2 diodes are reverse biased, correct? Because negative, this is positive is connected to negative here, negative to positive, this is reverse biased, and also this is reverse biased. So now how the current will flow, students, from positive to negative? So that is from positive it comes here, this is L2 is positive now, then through this diode it goes through R3, then it is through this diode it comes back to the minus, that is L1, correct? So like this, whatever may be the polarity of the input signal, the output is always positive. Okay, the output or direction is always from positive to negative through this resistor R3, and hence whatever the pulses that we are getting, the output signal that we are getting, it is always in the positive side only, and that is how the rectifier functions. So it is always in the positive side. Whatever we are getting, the pulses, the output, that is portion, the output portion is always a positive portion only in the output, and hence it is a DC signal. Okay, once we get that DC signal, then it is sent to the detector portion. As I told, Zener diode, when the certain Zener voltage or the reverse voltage or breakdown voltage is reached, it detects the value of that voltage. Based on that voltage, there is a current flowing in the Zener diode. Once that voltage is detected, then it is given to the optocoupler circuit or the optical isolator circuit. Here, this optical isolator, it is a circuit which separates this portion from the right portion. Is separating the left portion of the circuit from the right portion of the circuit. Now, how it is separating? This is a diode arrangement here, right? So initially the electrical signal is flowing here, right, in through the diode, and when it flows through this diode, it's emitting the light. The diode emits light. This light emitted by the diode falls on this phototransistor. Okay, so this is a phototransistor what we are seeing here on the right side. As it falls on this phototransistor, it is a phototransistor. See the name, phototransistor. That is, photo means light, then light energy is converted into electrical energy. When the light falls on this phototransistor, it starts to conduct, and the light energy is converted into electrical energy. That electrical energy is applied to this LED. Through this digital logic circuit, it is applied to the LED, and the LED is turned on. Now tell me, students, whether the LED is turned on when there is no input signal here at L1 and L2. Yes, I am not applying any signal to L1 L2. Whether the LED will be turned on? Yes or no?
No.
Whether the LED will be turned on when the input signal is not applied to L1 L2. Yes, please. Any answers?
No, sir.
No, exactly. Because when we are not applying any input signal to L1 L2 terminals, the LED cannot be turned on. It will be in the off state. The LED is turned on only when it is getting a suitable current. Okay, when it gets a suitable current from this optical isolator, right, only then it will be turned on. Okay. Like this, what is the importance of this circuit, students? The importance of this circuit is, this is the input section or the input module, where when the input signal is present, the LED will go on, LED will be turned on. It will indicate that the input signal is present. If input signal is not present, if input signal is not applied, then the LED will be in the off state, which will indicate that no input signal or no AC signal is applied to this input module. That is the importance of this internal module circuit or the input module circuit. Okay. So that's what the everything is explained here. The noise filter consists of capacitor and resistor R1 and R2, which removes unwanted signals due to contact bounce or electrical interferences. What is meant by contact bounce? Contact bounce means when we are pressing this push button, now you have a keyboard, right? In your laptops, on your PCs, right? You have a keyboard. When you press that key on the keyboard, before it comes to rest, it will bounce many times. It is not in the stable state. When you are pressing any key, you may feel that immediately you have got a 0 or 1 or A or B, whatever on the screen. But it is not like that. To come to stable state, it will take some time. When you press any key on the keyboard of your computer or on your laptop, before it comes to rest, it goes to many bounces. It bounces, okay, until it comes to a stable state. That is called as key bouncing. So that unwanted signal is removed by this filter circuit. That is a combination of R1, R2 and C. Similarly, if there is any electromagnetic interference, there is a nearby circuit which is producing a magnetic effect, and because of that magnetic effect, the current is flowing in this circuit, in our circuit. That is also unwanted signal, correct? That also is removed by this combination of R1, R2 and C. When push button is closed, 120 volt AC signal is applied to bridge rectifier. This results in low level DC output voltage that is applied across the LED of the optical coupler or the optocoupler. Zener diode ZD detects the voltage. What is the voltage at the input signal applied? That in terms of the DC voltage, it detects that voltage. When light from the LED strikes the phototransistor, it starts conducting and LED turns on. When the light from this LED is falling on this transistor, It is a phototransistor, and hence light is converted into electrical energy. It turns on. This LED, which is connected here at the output of this phototransistor, turns on. Optical isolator separates the higher AC input voltage from logic circuits. There's one more advantage of using this optocoupler. That is, if there is any one advantage is if there is any electromagnetic interference noises, that is removed. Right. Second advantage is if there are any variations in the input signal, transients or the variations or the fluctuations in the input AC signal. So those fluctuations are also removed by this filter circuit. Okay. So like this, it is having many advantages. One is it removes the key bounds. Then second, electromagnetic interferences or electromagnetic noises. And third one, the transitions or the fluctuations in the input AC signal is also removed by this filter circuit. A PLC input module has groups of inputs that share a common connection. Here we are having the many channels of the input with a common channel. Okay, the last one is the common channel here for this particular input module. Discrete input modules perform 4 tasks in the PLC control system. So what are these 4 tasks, students, performed by the discrete input modules? Can you tell me? What are the functions performed by the discrete input modules in the PLC control system? What is the first function it performs? Yes, first function. Just now we discussed all this, is it not? Any doubts in this block diagram, or on this circuit, students? Any doubts here in this diagram? Yes, please. Any doubts here, students? Any questions? Any difficulty in understanding here? Yes, please. Any difficulty in understanding? Following here, right? Yes?
Yes, sir.
Okay, good. 4 tasks or the 4 functions of the discrete input modules, just now what we discussed, are as follows. First function is it senses the input signal. It is a sensor here. Whatever the line voltage or the input signal is applied, that is sensed by this fuse and this input module section, the push button and the input module section. Second function converts input signal to correct voltage level. The input signal is converted from AC to DC. That is the required DC voltage level required for the PLCs. Okay. It converts from here 120 volts to 5 volts DC. The PLC operates at 5 volts. That we'll see next in the next points. It isolates the PLC from fluctuations in the input signal voltage or current. So if there is any fluctuation in the input signal, so that fluctuation is eliminated by this filter circuit. And there is optocoupler circuit which sees that if there is any fluctuations or any changes in the left side of the circuit, so that changes are not highlighted or they are not brought to the right side or the right portion of the circuit. Okay, because it is isolating, it is separating. That is the meaning of optical isolator. Only when the current reaches to a particular level, the diode, this LED will turn on and it will emit light. So until the current reaches to a particular level, the LED will not start to emit the light. So like this, if there are any unwanted changes or any not required changes that are in the left section of the circuit, those are also not sent or not passed on to the right section of the circuit.
So the bridge rectifier, can you sir briefly explain?
Rectifier circuit. You want me to explain rectifier circuit? Bridge rectifier. Okay, I'll come to that. Yes, I'll come to that. Now, bridge rectifier. This is the rectifier circuit. The rectifier. First thing that we know here is what is a rectifier. Rectifier is a circuit which is converting from AC signal to DC signal. It converts from alternating. Okay, the sine waveform. Right, the sine waveform is converted into a DC signal. Okay, that is a rectifier. Now in rectifiers, we know that there are two types. One is half wave rectifier, another one is full wave rectifier. In full wave rectifier, again there are two types, that is the center tap rectifier and the bridge rectifier. Okay, so here in this bridge rectifier, these are the four diodes which are used, which are forming the circuit for the bridge rectifier circuit. Okay, this is the circuit of the bridge rectifier. So these two diodes are connected in parallel, and these two diodes are connected in anti-parallel fashion. That is the circuit what we are calling here, the bridge rectifier circuits. These two diodes are connected in parallel arrangement, and the other two diodes are connected in anti-parallel. What is the meaning of anti-parallel? The negative of this is connected to positive here. The negative of this diode is connected to the positive of this diode. This is called as anti-parallel arrangement. Anti-parallel arrangement. Once the diodes are connected in this fashion, the reason why they are connected in this fashion is, now we are applying the AC signal here. At the input, we are applying the AC input, alternating input, that is a sine waveform. For the positive portion of the sine waveform, any two of these diodes are in on state. Okay. Now for the positive portion, what will happen is L1 will become positive, L2 will become negative. For the positive portion, L1 is positive plus polarity, L2 is minus polarity, minus negative. Now because of this, what will happen when L1 is positive, so this is positive come to here, so this positive is connected to positive of this diode and negative to negative L2, right? Similarly, this diode, when we come to this diode, so come to this L1, from L1 come to here, so it is positive to positive, negative to negative L2. This diode is also in on state. What are the two diodes? Now L1 is positive, L1 is positive, it is connected to negative of this diode, so it is off. This diode is off. Similarly, come to this, L1 is connected to negative, positive is connected to negative cathode of this diode, so it is also in the off state. That means for the positive portion, the two diodes which are in parallel are on state. For the negative half cycle, the remaining two diodes will be in the on state. Okay, so because of this, what happens here, students, for the positive portion, when the two diodes are turning on, the current flows through this resistor. Okay, current flows to the resistor, and when the other two diodes are also connected, that current flows in the same direction through this resistor. Okay, when two diodes are in on state, the current flows in the same direction through this R3, and when the other two diodes are also on state, the current flows in the same direction or through the same resistor R3. Because of this, what is happening here? Because of this, the output that we are getting is only in the positive side, in the positive portion. Clear here? The output that we are getting is only in the positive portion, that is above the reference level, above the zero level. Correct? So that is what it is called as the rectifier circuit. We get only the positive pulses, the positive portion of the applied sine wave signal. Clear? And hence it is called as the rectifier, or in particular, this particular circuit is called as the bridge rectifier circuit. Did I reach you, student, here? This particular, did I answer to your question? Is your question is clear here about the rectifier?
Yes, sir.
Okay, fine. Next, we'll see, this is the input section, what we discussed till now. Next is the output section. We'll go on to the output section. As we have two sections in the input section, the power section and the logic section. In the output side also, we are having two sections, that is the power section and the logic section. Okay, the power section and the logic section. This is our output circuit, output module block diagram. Here we are seeing, again, it is having two parts, two sections. One is the logic section, another one is the power section. Okay, so as there is a logic section, in this logic section, we are applying the signal, digital signal from the processor. Digital signal from the processor. Processor is nothing but the PLC processor here. Correct. So from the PLC processor, based on the program that is stored in the ladder diagram or the program that is stored in the processor, we are getting this signal from the processor. Okay, then this signal will operate this LED. This signal will operate this LED. Okay, and why we are getting the LED in the on state? Because of this signal, this digital signal from the processor. Correct. So the LED will be on because of this digital signal, because we have two states, on and off state. So when the digital signal is high, that is in the one state or the high state, then the LED will be on. When the LED will be on, then the current flows. The logic circuits operate here. These logic circuits make the current to flow in the optical or the optical isolation circuit coupler. Then in this optical circuit, it is same as that we discussed in the previous, that is in the input module. The optocoupler here, what we are getting, again there is a isolation between the two portions, that is the left portion and the right portion. Because of this isolation, right, I mean, there are many advantages as we discussed in the previous input module, that it is removing the unwanted variations in the left section and not reaching the right section of the circuit. Okay, then that the light falls from the diode on the phototransistor, the transistor conducts, and the electronic switch operates here. We'll see that what is this electronic switch. When this electronic switch operates here, then the load will be turned on. When the electronic switch operates here, the load will be turned. This is the symbol of the load. Right? The switch operates here, the load will be turned on. Okay, so like this, the load will be turned on only when the signal is coming from the processor and when the LED is turning on. The signal is coming from the processor based on the program or the ladder diagram that is stored in the PLC, in the processor of the PLC. We'll see that next, the CPU portion of the, that is a PLC, that will take up in the next class. Then based on this, the LED will be turned on, and based on the turning on of the LED, we are getting the load also turned on in the output side. Okay, so like this, the load will be turned on only if the input signal is present and the LED is turning on. So this is the basic idea behind this block diagram. Okay, we'll see in detail what is this block diagram, that is in the next figure. Logic circuits determine the output status. That is what it is. And the logic circuit, these circuits determine the status of the output. That is whether the load is in on state or in the off state. Output LED indicates the status of the output signal. Output LED indicates the status of the output signal. This LED, status of the output signal. That is whether the load is in on state or in the off state. Next figure, we are seeing the discrete AC output module, the simplified diagram as we did for the input module, that is explained in the next figure, operation of the circuit. You can see here. The signal is coming from the processor based on the ladder diagram that is stored in the processor of the PLC. Based on that, the LED is turning on. The LED is turning on, right? This is a digital logic circuit, which has only two states, on state or the off state. Based on this, the current flows in the circuit to turn on this LED of the optocoupler. When the LED of this optocoupler is turned on, the light falls on the phototransistor. This phototransistor, when the light falls on this, it starts to conduct. There is a conversion from light energy, optical energy to electrical energy. Then when this phototransistor conducts, it is operating this switch. Okay, so this is a switch which is called as the Triax switch. This signal what we are applying here is called as a gate signal. Okay, that means when a particular value of this gate signal is reached, this Triax switch tries to operate, or it starts to operate. Only when the signal coming from the transistor is at a suitable value, is at a suitable level, okay, that is applied to the gate signal, it starts to operate. That switch, Triax switch, starts to operate. Now this Triax switch, it is a bidirectional switch. Triax switch is a bidirectional switch. It operates in either direction. Okay, based on the signal that is applied to the gate terminal, it operates in either direction. Okay, now here when this signal is applied here from the phototransistor, what is happening is the L1 signal is applied through the fuse, right? Then this is positive to negative. So here it is coming and it is applied to the load. Okay, whatever signal we are applying here, L1 to L2, the signal, okay, only because of the turning on of the gate terminal. Okay, if this gate terminal is not operated, then there is no question of this L1 coming through fuse and flowing through the switch and turning on the load. When it happens only when the gate terminal is operated. Only then the signal comes from the L1 through fuse, it flows through the switch, and then it turns on the load. Now this Triax switch, it is a bidirectional switch. The current can flow from the bottom portion to top portion, that is from L2 to L1 or from L1 to EL2. And hence the signal that is coming to the load section is an AC signal. Because for the positive cycle, what is happening? The signal is coming from the L1 to L2. Okay, and for the negative cycle also, there's a negative portion flowing through the load, and hence we get the alternating cycle or the positive to negative. Both portions come to the load. Okay, both portions coming to the load. Okay, because of the bidirectional flow of the current that is flowing through this switch. Okay, both, that is positive portion that is applied to L1, that also flows through this that is a positive to negative. Okay, then when you are applying the negative portion, that also flows from L1 to negative to positive, then it flows to the load, and hence the signal that is coming to the load is an alternating signal, the AC signal. Okay, that means this Triax switch is used to operate the AC loads. Remember, important point is Triax switch is used to operate the AC load. Okay, the Triax switch cannot be used to operate the DC load, students. Remember, this Triax switch can be used only to operate the AC load because it is bidirectional in nature. It conducts in both the directions, and hence it is used to, or it is meant to operate the AC loads, AC alternating current loads, but not the DC loads. Okay, so like this is how the output module works. That is the output discrete AC module, functioning of the module. Okay, any doubts here, students? Any questions in the working of this, here in this block diagram or in this simplified diagram? Any questions? Any doubts? Yes, please. Any questions, students? Yes. Following here, right? Everyone? Are you following here, students? Did you understand this concept? The output module? Yes. Yes, please. The concept is clear here. Working of this, students. Am I audible, students?
Yes, sir.
Yes, please. Am I audible? Okay. Concept
Yes,
is
sir.
clear here. Working of this. Okay, fine. Good. So the operation is clear here. Digital logic circuit operates the processor, sets the output status according to the program stored in the processor of the PLC. When it is required for output load to be energized, a voltage is applied across the LED of the optocoupler. LED emits light, it turns the phototransistor on into conduction. Then it triggers the Triax switch into conduction. This is called as triggering the Triax switch. Triggering means what, students? When we are applying the signal from this phototransistor to the gate terminal, it is a 3-terminal device. This track is a 3-terminal. This is one terminal, gate terminal. One is the anode, another one is the cathode. Okay. Then when you are applying a certain level of the signal to this gate terminal, only then it turns on and then it starts to conduct. The switch is turned on. Okay. This particular action of applying the signal to this gate terminal of the track is called as triggering the Triax switch. Since the track conducts in either direction, output to the load is alternating current. As in the in other switches, what we are having on state and off state. But in Triax, we usually consider it as high resistance level and low resistance level. High resistance level means when resistance is high, what about the conduction? Conduction is very less. Correct. When resistance is high, the current flowing is very less. So it is as good as off state. It is open circuit. When resistance is less, what happens? Conduction will be more. V is equal to IR, Ohm's law. Try to recollect the Ohm's law. I is equal to V by R. When resistance is high, current is less. When resistance is less, current is more. Correct? Current is inversely proportional to resistance according to Ohm's law. I is equal to V by R, or V is equal to I into R. Now, what happens here? Resistance is high, current is less. When that is off state, when resistance is less, current is high. Here in the back, two states, that is high resistance state and low resistance state. Not called as off state and state. Here, they are called as high resistance state. That is the off state here. They are low resistance state. They are called as the on state. Output is the status of each output. Why the fuses are protected? I told you all the reason. They are the protective devices. For the output module, they are provided on a per circuit basis. That is, here for this channel, if you require a fuse, then it is provided here. For example, if you require a fuse for this channel, next channel, then a fuse can be connected here to this channel. If you want a fuse to be connected to this channel here, what I am showing you all, we can connect the fuse there. So this is called as per channel basis, connecting the fuse per channel basis. To provide a protection for that particular. Triax can be because it is meant for only the alternating current load. LED output indicator is on whenever the output load is output load is switched on, the LED status indicator is. It is not audible. My voice is not audible now. Now it is audible. Voice is breaking. Okay.
Yes, sir.
Yes, sir. Breaking.
Just 1 minute. Check. I'll just check. I'll use my headphone 1 minute. Hello friends, now audible? Students? Is it audible now, friends? Yes, please. Yes. Oh, still voice is breaking.
Audio not clear.
Audio not clear? Okay. Just. Now it is okay, students. Now check. Now it is okay.
Yes, sir.
Students. Okay, fine. Fine. So we were discussing about the output module here. So when we talked about the output module, discussed the various blocks. Triax output can be for control of AC devices. Transistor outputs can be used for control of DC devices. These are some of the important points that you all have to remember. Triax output can be used for AC devices, AC load devices. If we are connecting a transistor, then transistor can be used to control the DC devices. Transistor cannot be used for AC devices because it conducts only in one direction. Similarly, relay can be used for both AC and DC devices because it can be switched between many contacts So relay can be used for both AC load devices and the DC load devices, for both. Okay. Triac can be used only for AC load devices. Transistor can be used only for DC load devices, whereas the relay contact or the relay switches can be used both for AC as well as DC load devices. Okay. Some DC IO modules specify whether the module is for current source or current sink. This is one more important point here. Now, the meaning of current source. Current source means they are sending the current from the IO in module, from the module to the, that is say from the module to the field device. Okay, that is called current source. Okay, we are sending the power or the current from the input output module to the field device, so the from the module, whatever we are sending the current or the power, that is called as the current sourcing module, and the module, the field which is receiving, that is called as the current sinking module, the current sinking device. Try to clear here. Current sourcing means the module which is sending the current, the power, called the current sourcing module. Okay. Now we are say that we are sending the power or the current from the input output module to the field device. Okay. So the input output module here is the current sourcing module. It is the current source. It is a source of the power, source of the current. Okay. Whereas the other module, that is the field module, it is the sinking module. It is receiving the current. So it is called as the current sinking device. Current sink device. Okay. One is the source, and one is the sink. Source means which is sending the power or transmitting the current or the power. Sink means which is receiving the power, or which is receiving the signal, or which is receiving the power or the current. So that is called as the sink. Okay. Now here the point is, if the IO module is acting like a current source, then the field device will act like a current sink, because it is the other way, is it not? One is sending the power, another is receiving. Suppose if the IO module is receiving the current, then it is called as current sink. And suppose if the field is sending the power or the current to the IO module, it becomes the current source. It is either. What it means here, the IO module can
So voice is breaking
source
slightly.
the current sink. It is breaking. 1 minute. Now, are you audible, students? Am I audible? Students?
Yes, sir.
Audible now? First, it was not clear from beginning. Well, my voice was, you are able to listen my voice no, from beginning? Yes, students?
Yes, sir. In
I
the
hope
middle slide.
middle it was a little getting stuck. Okay, fine, no
Yes.
problem. Okay. We'll make up that. If you are having any doubts in between there middle, you can ask me. In the middle, if you have got any points which are not clearer to you, then you can ask about those points. So it is clear then, right? Okay. What we discussed here, students, the output section, the pulse. Once again, I'll quickly explain in brief. The output section, the pulse is applied here to the digital logic circuit. Based on that, the LED will be turned on. It will transmit the light to the phototransistor. Phototransistor will come into conduction. It will convert the light energy into electrical energy. Triac will be turned on. So this triac is a bidirectional switch. Okay. Based on the signal that is applied to this gate terminal, it's a 3-terminal device. This is a gate terminal. This is a one anode. This is a cathode. Okay. Based on the signal that is applied to the gate terminal, the current will flow from anode to cathode, or from cathode to that is from anode to cathode. Okay. Now, when we are applying the positive portion of the AC signal from L1, that will flow from this anode to cathode. Okay, that is this portion will be in on state. Then when we are passing the negative portion of the AC signal, then it will flow from this portion, that is the negative to positive, and hence at the load side we are getting the AC signal. We are getting both positive portion and negative portion of the AC input signal. That means the Triax switch can be used for only the AC loads, but not for the DC loads. Okay. So Triac outputs can be used for controlling of AC devices. Transistor outputs can be used for controlling of DC devices. Transistor, it is unidirectional. It can control only the DC devices. Then the relay can be used both for AC as well as DC devices, because relay can switch between multiple contacts. Okay, and hence it can be used for both AC load devices as well as for DC load devices. There are two types of devices here. One is called as a current sourcing device, another one is the current sinking device. Current sourcing device means the device, suppose say the IO module is sending the current to the field device, then the IO module becomes the current source and the field device becomes the current sink. Current source means which is sending the power or which is sending the signal, sending the current. Okay, then the other module, the field device, will become the current sink. Suppose if the IO device, IO module is receiving the current, then it will become the current sink, and the field device, if it is sending the current or the signal, it will become the current source. Okay, it is the IO module can act like a current source or the current sink, and the field device can also act like the current source or the current sink. Just try to understand here. Current source means which is sending the current, which is sending the current. Okay, and the current sink means which is receiving the current. Okay, that should be clear here. We'll move on to the analog IO modules. As I told in the beginning, the initial PLC modules were discrete in nature. They were only of digital type. Then later on, both digital and analog features were included in the PLCs so that they could be used for both controlling the analog signals of the field devices and also the digital signals of the field devices. Okay, so that is how the time evolved and the advancement has taken place in the PLCs. Analog devices represent physical quantities that have infinite number of values. Analog devices have infinite values. Okay, that is a continuous signal, sine waveform. It has many values, many valued input. Digital, only two, either 1 or 0, on or off. Typical analog inputs or outputs, they have the values ranging between 0 to 20 milliampere, 4 to 20 milliampere, or 0 to 10 volts. The analog signals in PLCs can have the values between 0 to 20 milliampere or 4 to 20 milliampere or 0 to 10 volts. Next is the PLC, that is analog input and output module used for measuring or displaying the level of liquid in a tank. I have sent you some videos on this. I hope you all have gone through the videos. So level transmitter here. This is the that is a container which is holding certain liquid. Okay, which is storing certain liquid. We want to measure the level of that liquid in the tank or in this storage. Okay, now if you want to measure the level of the liquid in this storage or in this tank, then that is first sensed by this level transmitter. Here you can see this portion here. This is called as a level transmitter, which will convert the level of the liquid in the tank into a suitable electrical signal. That electrical signal, the current or the voltage, will be applied to the analog input module after amplifying. After amplifying means, now say the voltage, let us say the liquid level in the tank is say at 5 centimeters, 5 centimeter level. So this 5 centimeter level is converted to say about 5 volts or say 5 millivolts, 5 millivolt signal. So as it is, the signal level is less, that is done by the level transmitter. The conversion of the height of the liquid in the tank to a certain voltage is done by this level transmitter. Once that 5 millivolts is obtained, then it has to be increased to a larger value so that that can be sent to the PLC, because PLC operates at 5 volts. Okay, so it is amplified. It is amplified. That is, the signal strength is increased from 5 millivolts to say about 5 volts. Okay, then it is applied to the analog input module. It will sense the analog input module. Just now we went out through all those blocks of the analog input module, the different blocks, right? From the analog input module, it is converted from analog signal to digital signal by the ADC. There is a block called as ADC, analog to digital converter. A for analog, D for digital, C for converter. This ADC will convert after the analog input module the analog signal to digital signal, and it will be applied to the processor or the PLC. Okay, it will be applied to the processor or the PLC processor here. Okay, this processor of the PLC will act based on the program that is stored in the processor. Based on the ladder diagram that is stored in the processor, it will act according to that, and it will send the required signal, the output signal, to the analog output module. Okay, so what is happening here? The processor will read the signal, the amplified signal from the analog input module, the digital signal from the module here, ADC block. It will act according to the program or the ladder diagram that is stored in the processor. It will act according to that, and it will send the required signal to the analog output module. Now, our output module is analog in nature, is it not? So again, the digital signal that is there in the processor, that has been converted into analog. For that, the another block is used, that is called as DAC, digital to analog converter, DAC. Okay, so this DAC block converts the digital signal to the analog signal, and is applied to the analog output module, analog output module. Okay. This analog output module will then operate this level indicator, and it will show the required level on this indicator. So that level is nothing but the level of the liquid in the tank, level of the liquid in the tank or in this storage, height of the liquid level in this storage, that is measured by this or indicated by this level indicator. Okay, so this is how it works, the analog IO modules, how to measure certain level of the liquid or height of the liquid in the tank using the analog input module, the processor of the PLC, and the analog output module, considering the indicator or the field device, that is the level indicator. Okay, we are measuring the height of the liquid level. So this liquid level, what we are measuring the store, this is also the field device which is connected to the analog input module, and the level indicator, this is also the field device which is connected to the analog output module. I hope this functioning is clear here, students. Function of this is clear here. Yes. Yes, students. Function of this analog IO module is clear here. Any doubts on this? Yes, please. Students, any doubts on this analog IO module?
No,
Are you
sir.
able to hear me? Clear, right? Okay. Okay, fine. Analog input module contains circuit necessary to accept analog voltage or current signal from level transmitter field
No, sir.
device? Okay, fine, good. The input is converted from analog to digital value for use by the processor. The circuit of the analog output module accepts the digital value from the processor and converts back to analog voltage or analog signal that drives the field tank level meter, or it measures the level or the height of the liquid in the tank. Okay. So here students, the analog input modules, they have multiple input channels, as I told just now at the beginning of the class. It may have a 4 channel or 8 channel or 16 channel. Okay, there are two types of analog input modules, one for voltage sensing, another for current sensing. Okay, one is used to sense the voltage, another type of analog input module is used to sense the current. And the analog sensors are the ones which measure the varying signals. For example, for temperature, pressure, flow, weight, level, all these are the analog signals because they are continuous in nature, they are continuously varying. Such of the signals, they are called as the analog signals or the analog sensors. So these analog sensors, they measure changing physical quantity over a specific range and generate corresponding voltage or current signal. Which are the different physical quantities or analog quantities that are measured by the PLC? They are the temperature, speed, level, flow, weight, pressure, and position. So these are few of the parameters that are measured by the PLC, which are analog in nature. Now let us consider one example here of a voltage sensing analog module. Voltage sensing analog module. Here I am trying to give an example of a thermocouple. Okay, hope you are familiar with the thermocouple. Thermocouple, suppose say let us consider two pieces of a wire, two pieces of electrical wire. We have two pieces. We are joining those two pieces at both the ends. Okay, the starting end of the two wires, we are joining them. The finishing ends, the end points of the two wires, we are joining them. Okay, then what I do is I apply temperature to both the ends. I apply temperature to this end and also to the other end. Okay, I maintain certain temperature difference between the two ends. When I maintain a temperature difference between the two ends, then the current flows in the circuit or the voltage is formed in the circuit. This particular concept is called as the thermocouple effect. Okay, it is the thermocouple effect wherein the temperature is converted into the voltage. Okay, and the effect is called as Seebeck effect. This you might have studied in your PUC level. Seebeck effect, correct? The temperature is converted into voltage by the effect of the thermocouple. Now when the thermocouple converts the thermal signal, the temperature signal, to voltage signal, that voltage signal is applied to one of the channels of the analog IO module. Here I am considering the Allen Bradley Micrologic 4 channel, that is Allen Bradley type of the PLC manufactured by Allen Bradley. Okay, which is having 4 channels. It has 4 channels. So that among those 4 channels, I am using 1 or 2 channels to collect the voltage coming from the thermocouple. Okay, so I am receiving that voltage, and so that I can send that voltage from the thermocouple, whatever voltage is obtained, I can utilize for some other blocks, or I can transmit it to some other blocks which I require. To whatever blocks I require, I can transmit that voltage to different blocks. A varying DC voltage in the low millivolt range proportional to the temperature being monitored is produced. What is a thermocouple? I told thermocouple is a block which converts the temperature to voltage. Okay, it is converting temperature to voltage. That conversion is done, and then the proportional to the temperature, the voltage is produced. So just now I gave the example of the level of liquid in the tank. If it is the level is say 5 centimeter, you may get a voltage of say 5 millivolts. The level is say 9 centimeter, you may get a voltage, output voltage from the transmitter as 9 millivolts. So it is proportionate always. Okay, it is producing proportionate input and outputs. Here also thermocouple produces proportionate output voltage with respect to the temperature input. The voltage is amplified and digitized by the analog input module and sent to the processor on command from a program instruction. Based on the program that is stored in the PLC, the PLC processor operates or it functions so as to produce a suitable output signal. It produces a suitable output signal. Okay, based on the ladder diagram that is stored in the PLC. Okay, or the program that is stored in the PLC. The change from analog signal to digital signal is done by the analog to digital converter. That was what I told. EDC is the block which converts from analog to digital, and DAC, digital to analog converter, is a block which converts from digital signal to analog signal. Analog voltage input modules, they are of two types. Now, analog input voltages, there are two types: unipolar and bipolar. Unipolar means it is only in one direction, say from 0 to 10 volts, 0 to 15 volts, 0 to 5 volts. It is always in the positive direction. 0 to plus 5 volts, 0 to plus 10 volts. Okay. Bipolar means negative as well as positive. It includes from the negative range and also the positive range. It is say from minus 5 volts to plus 5 volts, minus 10 volts to plus 10 volts. So such of the voltages, they are called as bipolar. Okay. Unipolar modules can accept an input signal that varies in the positive direction only. The field device outputs 0 volts to 110 volts, and the unipolar modules would be used. Bipolar signals swing between maximum negative value to maximum positive value. The field device outputs minus 10 volts to plus 10 volts. A bipolar module would be used. Now, what is resolution? We have to know what is a resolution. Definition of resolution. Resolution of the analog input channel, it is the smallest change in the input signal value that can be sensed or detected. Okay, so resolution is the smallest change in the input signal that can be detected or that can be sensed. Suppose, say, if there are two input signals you are applying. Okay, one input signal, say you are applying, say 1.2 volts, another one you are applying 1.23 volts. Okay, that smallest change, that is 1.23 minus 1.2, it is 0.03 volts. The smallest change that can be detected by the channel, by the analog input channel of the analog IO module, that is called as the resolution of that analog IO module. Resolution of that analog IO module. Okay, this is a definition that you have to remember. Resolution of the analog input channel, it refers to the smallest change in the input signal value that can be sensed or detected. Okay, that's all, students. In today's class, we have gone through the various points, starting from the, that is, we started the discrete IO module. Okay, which are the discrete input devices, discrete output devices. Then we discussed various points about the discrete IO modules. What is a PLC power supply block? How it transmits the power to the backplane, and from backplane it is sent to the IO module. Then we discussed also the AC input module block diagram, one of the important blocks. Okay, how it is converting from the input AC signal to DC signal by bridge rectifier, detecting the voltage level. Then using the optocoupler, it is transmitting to the other section, and then operating the LED to indicate the status of the applied input signal. Then the simplified diagram of this diagram we explained here in detail. What is the fuse, what is push button, what is R1, R2 and C combination? It is a filter. R1, R2 and C combination is a filter which removes the unwanted signals in the applied input signal. Then the bridge rectifier circuit, that is a combination of 4 diodes. Threshold detector, which is a Zener diode. It's a symbol of the Zener diode. Okay, normal diode symbol is different. This is the symbol of the Zener diode. Okay, then this Zener diode and R3, they act in such a way that they detect the voltage. And from that, it is sent to the optocoupler. From optocoupler, it is turning on the LED. Next was the output module block diagram. This was the output module block diagram. Okay, here the digital signal from the processor, it operates the LED. Then from there to the optocoupler, Then the electronic switch, that is a Triax what we are using. It is a bidirectional switch which is operating the load or which is turning on the load. That's what is explained here in this diagram. From the LED to the optocoupler, from there to the track, and from the track to the load, turning on the load, which indicates the status of the LED, indicating that the signal is being sent to the load, okay, or the load device is turned on, load is turned on. Track, it operates only for AC load devices. Transistor is for DC devices, DC load devices, whereas the relay is both for AC as well as DC load devices. Then the concept of current source and current sink was explained. The module which is sending or transmitting the current or the power is the current source, and one which is receiving the current or the power is the current sink. Then later, analog IO module. Here we have taken the figure of the analog IO module, the level transmitter sending the signal, sensed the height of the signal or the level of the liquid in the tank is sensed, and that is sent to the analog input module. Okay, that is converted into a suitable voltage, say about 5 millivolts. It is amplified from 5 millivolts to 5 volts, sent to the analog input module. From the analog input module, it is sent to the processor. The processor, based on the ladder diagram or the program that is stored, is converting the signal. It is providing the required output signal based on the ladder program that is stored in the processor of the PLC, memory of the PLC. Then from that output, it is again converting from digital to analog. In the input side, it is converting analog to digital and sending to the processor. While giving it to the output, it is converting again from digital to analog and giving it to the analog output module. From the analog output module, it indicates the level of the liquid in the tank on the level indicator. Okay. Then we also discussed the point considering the Allen-Bradley thermocouple input module, how the thermocouple converts temperature to voltage, and how that voltage is measured by the 4-channel Allen-Bradley PLC. Then the points about ADC, analog to digital converter, unipolar type of analog voltage and bipolar type of analog voltage. Unipolar means it is only in one direction, positive direction always. 0 to 110 volts or 0 to plus 10 volts, 0 to plus 5 volts are all unipolar. Bipolar means negative range as well as positive range, minus 5 to plus 5, minus 10 to plus 10, like that. Then last one was the definition of resolution. The resolution of the channel or the analog input channel is the smallest change in the input signal that can be detected by the module. Such smallest change is called as the resolution of that channel. Okay. Any questions here, students? Anything you all want to ask? Hope it was clear to you today's discussion. And some of the materials which all are required, I'll be sending you all those materials. Please go through them. Any questions here, students?
No, sir. No questions.
Okay, fine. Godi, any questions? Godi? Saval? Saval, any questions?
No, sir.
Understood today's topics? Okay, good. Baswaraj? Chinchkandi? Baswaraj?
Yes, sir.
Any questions, Baswaraj? Anything not understood?
Nothing, sir. Nothing, sir. Understood the concept.
Good. Okay. Mahesh Kulkarni?
Yes, sir.
Understood today's topics, Mahesh?
Yes, sir.
Everything is clear?
Yes, sir.
Any difficulty
Clear
in
for me.
understanding? Any difficulty in understanding? Okay, fine.
No, sir. No.
Okay,
Clear, sir.
fine. Inoch D'Souza? Inoch?
Yes, sir.
Today's topics are clear, Inoch?
Yes, sir. Topics are
Any
clear.
problem in understanding?
No, sir.
Okay, good. Okay. Then I will let you know when will be the next class. Okay. So that we'll continue with the next topics in our next class. Okay. Thank you. Okay, I have marked your attendance. Mahesh, I will mark yours. Okay.